Last lesson, we used the mathematical definition of what the Fourier transform is to derive a few basic Fourier transform pairs, and it was pretty difficult. This lesson, we're going to be using Fourier transform tables and take advantage of the fact that other people have done the work for us. I'll go over the table that we're going to use in this course and that you'll have access to for the next test, for the final exam. And I'll give an example of a pretty impressive song that someone I know set some music about the Fourier transform. Last, we'll work 3 examples, an easy, a medium, and a hard one. And in the middle, we'll talk about how to take the inverse Fourier transform. So let's begin with a look at the big picture of what Fourier transforms are and how they fit in with other circuit analysis methods we've already introduced. You begin with the circuit, and there's different types of inputs. You might have a DC input to that circuit, and if you do, you'll use EE230 techniques from circuits 1 to analyze it. Those are things like nodal, mesh, superposition, source transform, and of course the big daddy of them all, Ohm's law. But we quickly moved into sinusoidal steady state behavior, things that were cosine waves that went on forever, unlike, that's our 0 point, our DC signal. So this is an input, gives rise to a different class of solutions. We use phasors. And in phasors we replaced inductors with J omega L. We replaced capacitors with 1 over J omega C. And then we went back to circuits 1 methods to analyze them. At the beginning of this course, we began analyzing functions that were right-sided. They were multiplied by some sort of U of t. They look like that, for instance, but they start off at 0. And for that, we used Laplace transforms. Then we moved into any periodic type of input. Goes on forever, but no longer does it have to be sinusoidal steady state now. It could be, say, a square wave or a triangle wave. And for that, we used Fourier series. And now we're going to use any kind of input. Maybe it's an impulse. Maybe it's a sinusoidal steady state. Maybe it's a periodic waveform. Maybe it's some sort of weird-looking aperiodic waveform, like this boxcar. And this anything, when we put in, can be analyzed with a Fourier transform. Sounds a lot like the Fourier series, but it works on both periodic and aperiodic signals. So let's get started by looking at the Fourier transform table.